Hello, Algebra 1 students. Mr. Ford here with another homework tutorial. This is 713, problems 35 through 41. Let's go. 35, your banker shows you the graph to write to explain what you can earn if you invest with him. Does this graph represent simple or compound interest? The answer to that is simple. And I can tell. How can I tell? Because it's a linear graph. To write an equation for how much money you have as time passes, let's see. Let's let x equal the number of years and y equal money. It would appear that y is equal to, I'm going to say 500. Looks like that's what the y-intercept is right there. Plus, if I'm looking at the slope on this case, it looks like every year you get 100 extra dollars according to this scale there. So I'm going to say plus 100x. There you go. I think that works pretty nicely. 736, each table below represents an exponential function in the form of a times b to the x. Find a corresponding equation. For that, for a, we're going to need the zeroth term. And for b, we're going to need the multiplier. So right away for table 1, I noticed that we kind of have to multiply 2 steps here to get from 3 to 75. I'm guessing it's going to be a whole number. Usually a really good way to solve this would be take 75 and divide it by 3, which gives us 25. And now that's not what's going on there, but 25 is what you multiply 3 by to get 75. So if you think about this, what can you multiply twice by itself to get 25? And the answer there, the square root of 25, is the number 5. So I believe what's going on here is we're multiplying by 5 and then multiplying by 5 again. So this would be 15, and sure enough, 15 times 75 is 5. We don't need to fill out the rest of the table because I think we have everything. We have the zeroth term, and we have the multiplier. So I believe this equation is y equals 15 times 5 to the x power. Just like that. Over here in question B, they only gave us 2 numbers to work with. So to find the multiplier, we're going to need to take 77.312 and divide by 96.64. And so for that, we're going to grab a calculator. I'm going to make my calculator cam nice and big here. I'm going to clear out everything else that's on there. 77.312 divided by 96.64. And that will give us 0.8, which I believe is a very solid multiplier. Now, we actually are going to need the zeroth term, and for that, we need to go back in time. We need to divide by 0.8 to go up on this table. So 96.64 divided by 0.8 will give us 120.8, which I believe is this term right there. And if we divide that by 0.8, we will get 151, which I believe to be the zeroth term on this table. So the equation is going to be y equals that zeroth term times the multiplier of 0.8 to the x power, just like the problem right next to it. Again, you can pause the video right now and take a look at the work on those problems again if you feel like you need to take more time. I'm going to move on to the next question. 737. Tickets for a concert have been incredibly high demand. As the date of the concert draws closer, the price of tickets increases exponentially. Key words there. The cost of a pair of tickets was $150 yesterday, and today it is $162. Assume each day's percent increase from the day before is the same. So what's the daily percent rate of increase, and what's the multiplier? So we what we want to do is divide 162 by 150, because that will tell us kind of the rate of change, or I guess the growth here in this case. And for that, on my calculator, I'm getting 1.08. So the multiplier, that's 1.08. But the daily percent rate of increase is 8%. Because 8%, if you write it as a multiplier in growth, is 1.08. What will be the cost of a pair of concert tickets 1 week from now? Well, now it's 162. So what I want to do here is take 162 and multiply it by 1.08. 1 week is going to be 7 days. So I believe this is happening every day since we went from yesterday to today. So we want to go to the 7th power there. We want to do 162 times 1.08 to the 7th power, which I'm guessing is $277.64. Since we're dealing with a very, dollars and cents problem, we should round to the nearest hundredth so we can get there. What was the cost of a pair of tickets 2 weeks ago? So in this case, we're actually going to go backwards quite a bit. we're actually going to use a little bit of clever thinking here. I'm going to take the $162 that was there, and I'm going to divide by 0.8. And really what we got to do is divide by 0.8 like, well, ooh, I got a good idea. How about this? We take 162, and we multiply by 0.8, or sorry, 1.8, 1.08. If my eraser could work today. Oh, boy. I think it might be time for me to get a new pen. This doesn't seem to be working for me right now. Okay. Let's take 162. We're going to multiply by 1.08, but since we want to go back in time, we're going to raise this to the negative 14 power. 2 weeks ago means x is going to be negative 14, I think. And I think that will work because negative powers actually go to the bottom of the fraction where they become division. That's what we want to do. So 162 times 1.08 to the negative 14th power, $55.15. And I believe that's the answer that we want for that problem. 738. Let me zoom out a little bit. If you need to take another look at it, you can pause the video right now. 738. Dusty won $125,000 on the Who Wants to Be a Zillionaire game show. He decides to place the money into an account that earns 6.25% interest, compounded annually, and plans not to use any of it until he retires. Write an expression that represents how much money he will have in T years. Well, okay. We're starting with the 0th term, which is how much money he has. And he's earning 6.25% interest compounded annually. This is growth, by the way. So we want to take that 0.0625 and put a 1 in front of it. So the multiplier we're going to use is 1.0625, like that. So I believe our expression is going to be something like this. Y equals 125,000 times 1.0625, all raised to the x power. I believe that's what we're kind of dealing with there. We're taking $125,000 and multiplying it by 1.0625 every year. And we want to know how much it's going to be worth in 23 years, so let's try that. Let's make it, here comes the calculator, 125,000 times 1.0625, all raised to the 23rd power. It's going to be a lot of money, a little over $500,000, 504,000. 52 and 30 cents. That's how much money I believe it's worth when x equals 23. In this equation right there. Okay, go ahead and turn the page. Let's go to 740. We got to solve a couple systems of equations. So, question A. Let's jump right into it. I noticed right away in this problem that you got negative 2y and positive 2y, which is a good thing for us because we're just going to use elimination to solve this problem. We're going to add both equations to each other. Oh, no, this happens all the time. There's a glitch in this program where if I select the highlighter, I have to close the whole program out again and restart it. So I had to do that. Stand by in this video. We were doing so well, too. Things were cruising along so well. It's going to have to think for a minute. Oh, good. And it popped us right back to where we were, which is good. Okay. So we're going to add both equations to each other. So 3x plus negative 2x is just going to be x. That's nice. These guys cancel right out. And 14 plus negative 10 is just 4. And so one step later, believe it or not, we actually have one of the variables solved for. X has got to be 4. But before we can leave this problem, we have to solve for y also. So I'm going to take the original top equation over here. This is 3x minus 2y equals 14. And we are going to plug in a 4 for the x right there. We just learned that x is 4. So we have 3 times 4 minus 2y equals 14. And that's actually cool because 12 minus 2y equals 14. And if you subtract the 12 on both sides, we get negative 2y equals positive 2. And that means that y has to be negative 1. And before we leave the problem, I'm just going to, in my head, spot check to make sure that actually works. Is negative 2 times 4, that's negative 8. And plus 2 times negative 1, which is negative 2, it does in fact equal negative 10. So it works in both equations. And that's what we want to see there. Question B is very similar, but this time we're going to use substitution because we were told that y is equal to 5x plus 3, and there it is right there. So we're going to take the bottom equation and we're going to replace that y with 5x plus 3. which now equals 10. This is called substitution. We're just replacing y with another version of y. And the nice thing is that these now have the same variable. It's all x now. So let's go ahead and distribute our -4, and we will have a good time. -2x minus 20x minus 12 equals 10. This gives us -22x. And we add the 12 to both sides. Oh, I shouldn't do that yet. I should not try to do more than one step at a time if I'm modeling what I want you guys to do. Now I'm going to add the 12 to both sides and get -22x equals positive 22. And that means that x has to be -1. -22 times -1 would give you positive 22. Substitution usually has a little more work on the front end, but the back end is very easy because all we're going to do is take our newfound variable for x and plug it in for y right up there. This is y equals -5 plus 3. And that becomes y equals -2. So our answers are -1 and -2. Oh, almost the same answer. I thought so. Which system is solved by a substitution method? System B. Which system is best solved by elimination? System A. That's it. And the easiest homework question we've had in forever. If you flip a fair coin, what's the probability that it comes up heads? 0.5. Or 50%. Or 1 out of 2. And it's the same for the other question. We haven't talked about stats or anything like that this year, or probability, but that's the thing to keep in mind. Really easy question. A fair coin is 50-50. That's going to preview for what we're going to do tomorrow also. So, have a great day. I will see you in the next video.